Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad algebra problem, and here we have 3 to the power of n plus 2 to the power of n equals to 35, and we solve this problem for the values of n. So the very first thing we are going to do is here first we rewrite this equation as we have 3 to the power of n and we write it as 3 to the power of n, and we just multiply 3 by 3, multiply and divide the exponent of this term by 3, and similarly this term is also multiply and divide by 3, its exponent, and it is equals to 35. So that in the next step we rewrite this equation as here we multiply 1 over 3 by the exponent n, and we obtain 3 to the power of n over 3 and its whole cubed, plus here we get 2 to the power of n over 3 and its whole cubed equals to 35. And now here we convert this exponential equation into the cubic form, so that here we take 3 to the power of n over 3 equals to a. We just take a equals to 3 to the power of n over 3 and b equals to 2 to the power of n over 3. We make these two substitutions in the above equation, so that the above equation will becomes in this form: a cubed plus b cubed equals to 35. And now in the next step we apply the cubic formula in the left hand side, and we get a plus b times of a square minus ab plus b square, and it is equals to 35. And here you remember one thing is that our a and b must be an positive integer. So a or b belongs to positive integer because a and b are the exponential function, and the other condition is that a and b is not equals to 1. So now we focus on the left hand side, and you see that we have two factors multiplied by each other, but in the right hand side we have only one factor, so that we convert our right hand side in two factors. So we have there are four possibilities in which you get the factors of 35. So that the first factor is that if we multiply 1 by 35, you will get here 35, and when we multiply 35 by 1, then you again get 35. And the third possibility is that 5 times of 7 is 35, and 7 times of 5 is also 35. So we have these four possibilities here, and now we check that in which possibilities are true for this situation. So if you focus on the left hand side, and we have a plus b times of a square minus ab plus b square, but if you make the relation between a plus b and this term, then we see that a plus b is less than a square minus ab plus b square in general. So here we choose any two factors in which the first term is lesser than the second term. So now we check this condition here, and you see that if in the first situation we have 1 is less than 35, so this condition is hold, but here 35 is greater than 1, so this condition is not hold, we choose this one. And similarly here you see that 5 is less than 7, so we choose this, and 7 is greater than 5, so we reject this. So we have these two possibilities, and now we compare these two possibilities one by one. So now from the first possibilities, and we have in case number 1, we first compare a plus b into this term by the first situation, which is 1 times of 35. So that here first we check that or compare that a plus b equals to 1 and a square minus ab plus b square equals to 35. And now we solve this these two conditions or these two equations, and we check that what we can do. So that here first we just take the square of this term on both of the sides, and we get the output of this term after taking the square is a square plus 2 times of ab plus b square equals to 1. Here we take, and now we subtract these two equations, and we get this is negative sign, this is negative, and also this is negative. So here you see that these positive and negative are gone, and these are also gone, and we add these two, 1 minus ab, and minus ab equals to minus 2 times of ab, and it is equals to 34. So here we get the value of ab equals to minus 34 over 2. Sorry, this will becomes minus 3, because this is minus ab, and minus 2 ab equals to minus 3 times of ab, so this will be over 3. So but here we rejected this case, and reason is that we uh, call that our a and b are positive integer, but here the product of ab not gives the positive integer, so that we will rejected this case. And now we proceed case number 2. So in case number 2, we have the other possibility in which we compare a plus b times of a square minus ab plus b square from these two terms. And here we obtain a plus b equals to 5, and we take a square minus ab plus b square equals to 7. So here we call this as equation number 1 and this as equation number 2. So here we get the value of a from equation number 1, and we write it as a equals to 5 minus b, and we name this as equation number 3. And now we substitute the value of a in equation number 2. So equation number 2 implies 5 minus b square, because when we put the value of a here, then we get 5 minus b square minus 5 minus b times of b plus b square, and this whole equals to 7. And now we simplify this equation, and we open the square of this term, and we get 25 plus b square minus 10b, and we multiply this minus b on both of the terms, and we get minus 5b plus b square and plus b square minus 7 equals to 0. We move the 7 in the left hand side. And now here we add or subtract the like terms, and we get b square plus b square plus b square equals to 3 times of b square, and minus 10b minus 5b equals to minus 15b, and 25 minus 7 equals to 18, and this whole equals to 0. And now in the next step, you see here we have 3 with a common term, so that we divide each term by 3 on both of the sides, and we obtain b square minus 5b plus 6 equals to 0. So this will becomes in quadratic form, and now we easily make the factors of this quadratic equation. So that the factors of this equation are b square minus 3b minus 2b plus 6 equals to 0. So here we take common b from the first two terms, and we get b minus 3, and here we take common minus 2, and we get b minus 3 equals to 0. So now in the next step, we take common b minus 3 from these two terms, and we get b minus 2 equals to 0. So here we have two possibilities. The first is b minus 3 equals to 0, and the second is b minus 2 equals to 0. So in this case we have b equals to 3, and in this case we have b equals to 2. And now we put the value of both values of b in equation number 3. So this is our equation number 3. A equals to 5 minus b. So we write here a equals to 5 minus b. And now we put the value of b here, and we get the value of a equals to, when we put b equals to 3, then we get a equals to 2. When we put b equals to 2, then we get a equals to 3. So we have two pair of solutions AB. The first is AB equals to 2 3, and the second is AB equals to 3 2. So that here we rejected this case because this case cannot gives us the integer solution, and we proceed here this case only. So in this case we have a equals to 3 and b equals to 2, and in the start of the problem we take here a equals to 3 to the power of n over 3 and b equals to 2 to the power of n over 3. So we back substitute these two values here, and we move towards our final answer. So that we put the value of a, it is 3 to the power of n over 3 equals to 3, and b equals to 2 to the power of n over 3 equals to 2. And now we compare both of the sides, and you get n over 3 equals to 1, and here we get n over 3 equals to 1. So in both of the cases you get the value of n equals to 3. So this is the our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.